Hello guys, good afternoon. So today the purpose of my video is to be briefly explanation on the HB circuit. So I will discuss in this video is to which components are required and how to make HB circuit and what which things are required and which safeties and all our the stuff to making this an perfect circuit for our desired project like it is our semester project and this like HB circuit. So start this video. So this is our report and the this supervisor name is our Sarmadamil Gufar. And these are group members and project topic is to be HB. So this is our abstract of this report. Basically our view of the product like HB. And this report details the investigation into the HB's motor direction controller circuit. The objective is to comprehend the BGT's base circuit by analyzing its various aspects, including circuit functionality, response in different scenarios, and motor control. Additionally, the circuit components and their respective values will be discussed. Through this report, we aim to comprehend the HV circuit applications and conceptual functioning resistor, battery, optocoupler, and BGTs are essential components required to complete this circuit. This report will also explore the HV circuit using the uses and applications. In the end, we will talk about the cost of the components we use in the project. So let's move introduction. So project of H-bridge. Basically, H-bridge is a type of electronic circuit commonly used to control the direction and the speed of motor. Means it direction, what direction, bidirectional, like move forward or backward, in this way. So it consists of four switching elements. Typically transistors is transistor is PNP and NP. NPN arranged in the shape of letter H. When properly controlled, the H bridge allows the motor to rotate forward or reverse by changing the direction of the current flowing through it. Like a transistor is wave like a switch. In case of using bipolar junction transistor BGTs in an H bridge configuration, the transistors act as a switching element, as you know. And BGTs are three terminal devices that can amplify or switch electronic signals. They have three layers of semiconductor material: the emitter base, meter base, and collector. The NH-bridge circuit transistors are usually arranged as two complementary pairs, which with each pair controlling the current flow in one direction, like one forward or backward. The H-bridge circuit with VGTs typically includes NPN transistor for the top switches and PN and P2 transistor for the bottom switches. This arrangement allows the current to flow through the motor in either direction, and depending on which the transistors are turned on or off. So the control the HB circuit with BJTs, a control signal is applied to the base switch transistor by turning on or off, like when you on or off the specific transistors in particular sequence. The desired motor direction and speed out can be achieved. Following them, they rotate the motor forward to the top right and bottom left transistors would be turned on like forward, and when the top left and the bottom right transistors would be turned off, reversing the motor direction which involves the reversing on off states of the transistor. Like when you one on an NPN and one on PNP, it moves the direction clockwise, rather it is not, and rather it is anti-clockwise. It's important to note that when using BGTs in HV circuit, appreciate current limiting resistors and diodes are often added to protect the transistor from excessive current or voltage spikes generated by the motors. So this is our module of motor. When four switches like switch 1, switch 3, 2, 4, this is the VCC applied to the circuits. This is our desired motor. You moved forward or backward direction. This is ground for the current given to the this extraordinary ground current is going to the ground. HP circuits with BGTs are commonly used in robotics, electric vehicles, and various applications where precise control over motion, direction, and speed is required. They provide efficient and reliable method by direction motor control, like some things. So this is our the direction flow, current flowing, VCC giving to this way and the motor this way to going to the ground, and this way the VCC going to this motor enter and this going to the ground. Basically two ways purpose, like left from the left side of the circuit and from the right side of the circuit. background and motivation. We see that the split circle with BGTs are gained significantly popularity and widespread use due to its ability to control the direction and speed of motor. It has become a fundamental components in many electronic systems, particularly in robotics, electric vehicles. The background and motivation behind the development, we use bridge with basic and attributes have effect like motor control. In our circuit, we basically control the motor in both directions. Nevertheless, is used in the robotics requires efficient motor control to achieve desired movements and functionality. By using H-bridge circuit with BGT, robotic system can perform tasks that involve the precise motion control such as locomotion, arm movement like robotic arm left, right, move forward, backward, something the gripper control. The H-bridge allows robots to move in different directions and vary their speed, enhancing their versatility and function. As you know, electric vehicles. The rise of electric vehicles necessitates sophisticated motor control system. H-bridge circuit with BGTs are extensively used in EVs to control the motor responsible for driving the wheels. With an HB, the vehicle's motors can operate in both forward and reverse directions, enabling accelerations, declarations, and generating braking. The ability to control the motor speed is crucial for achievement optimal performance, efficiency, and safety in electric vehicle. Sustainable development goals. Basically, HPs are often used in power electronics and control systems, including renewable energy applications such as solar, wind, and power. By efficiently converting controlling electric energy, H-bridge can support the generation, distribution, and utilization of affordable cleaner energy. H-bridge plays a crucial role in the development of advanced control system and automation technology, enable to precise control of motors, actuator, and other devices, contributing the enhancement of industrial process, transportation system, and infrastructure. When you must may know that the basically the sustainable development goals problem statement. The next is one significant problem is the inefficient control of HBD circuit. Basically, these circuits consist of four switches that can be turned on and off in different combinations to control the direction and magnitude of current flow. Inaccurate and imprecise control signals can lead the subopot, suboptimal operations, resulting in reduced efficiency and performance of the control devices or systems. Inadequate control can also cause issues such as excessive heat generation, noise, and even device failure. Furthermore, H-bridge circuits may face challenges related to voltage and current ratings in high power applications where large amount of current or voltage are involved. H-bridge must be designed and configured to handle these levels without compromising safety or performance. Overloading or mismatched rating can result in device failure, overheating, and potential hazard. So I suggest you to must use the heat sinks in the circuit. So basically, the objective of the project it's basically design an HBG circuit using BGT to control the direction of motor, optimize isolation, and flyback diode. The motor runs at 9 volt and draw a maximum of 2 ampere. The motor is operate continuously for 50 minutes. And this objective from our as project and guideline like teacher given to us. And cost analysis, this price of these all components you must see and watch the description of the project. So the HBG basically circle allows the current to flow in either direction through the load by selectively turning on and off the switches in the circuit. By activate specific combination of switches, the polarity and magnitude of the voltage applied to the load can be controlled. This makes it suitable for applications required forward and reverse motion such as motor control, robotics, electric wheels, and vehicles and industry machines. And the next thing is the timeline of the project. The HBridge concept and its application have evolved over several decades. Here is a rough timeline highlighting significant milestones and development related to the HBridge circuit. We move in 1960s. The HBridge circuit topology is initially developed by motor control application transistor-based HBridge configured. Start the enable next the development of motor HBridge in the 1970s. We use solid state devices such as the power MOSFETs and IGBTs become prevalent in HB circuits. These devices offered improved performance, higher switching speeds, and increased power handling capabilities. And next, in 1980s, HBDs gained popularity in industrial applications for precise control, electric motors, and actuators. The use of microcontrollers and dedicated motors control facilities more sophisticated control algorithm and feedback systems. In 1990, the application has Circle expanded into diverse industries including robotics, automation systems, and renewable energies. The development of more efficient power devices and gate-driven technology enhances the performance and efficiency of HB Circle. 2000s integration of advanced control algorithms and digital signals processing techniques with HBD circuits allows for more precise control and motion profiles. Motor control system with closed loop feedback and sensorless operation becomes more common. 2010s HBD circuits find widespread use in electric vehicles propulsion systems enabling efficient control of motors propulsion creating breaking the demand for high power handling capability increase efficiency driver further advancements in HBD design and power semiconductor technologies. 2020's ongoing research focusing on improving the efficiency and reliability of HP circuits, reducing energy losses during switching, transitions, and enhancing control algorithms for various applications. The development of bandgap semiconductors such as silicon carbide, CIC, and gallium nitride offers new possibilities for high power densities and increased operating frequency in HP circuits. Telemetry provides a general overview of the evolution of HBD circle, who is development under development, but it's important to note that the investments and development in this field have occurred gradually over time with continuous improvements and refinements in design, control techniques, and component technologies. So next thing is the methodology. What's the method for the building or making of an HBD? Building an bridge using bipolar junction transistor involves the designing and connecting the transistors and other necessary components to achieve bidirectional current control. Here is step-by-step methodology. Firstly, select components. Choose appropriate bipolar junction transistor NPN PNP with suitable voltage and current rating for your application. Consider factors such as load requirements, power supply voltage, and desired switching frequency. Determine the power supply requirements for your HV circuit. HV ensure that voltage rating for the power supply is incompleted with the transistors and load. Consider the current handling capability of the transistor to avoid overheating and damage. We use a master heatsink or some and for the safety purposes. Design the control circuit. Design control circuit that will drive the transistor. This can be achieved using microcontroller logic gates or dedicated HV driver ICs. The control circuit generates assist signals to control the switching of the transistors, enabling bidirectional current flow. So next thing is connecting the transistors. Connect the NPN PNP transistor to form the HV circuit. The connection typically involves two upper transistors NPN and two lower transistors PNP arranged in the shape of hash. Connect the collector of each PN transistor to the power supply positive terminal and the emitter to the load. Connect the collector of each PNP transistor to the load and emitter to the power supply negative terminal. So this is the main purpose. This is the main things you must know. And protection diodes. They protect the resistance from voltage spikes during switching transition and flyby diodes across each transistor. Connect the node of the each diode to transistor collector and cathode to the transistor emitter. Implement gain resistor including base or gate resistor for each transistor to limit current flow and ensure proper transistor operation. The value of these operator resistor depends on the specific transistor characteristics and the desired switching speed. Consult the transistor data sheets and apply the notes for appreciate resistor value. Connect control signals. Connect the control signals for arm the control circuit, the base or gate terminals of the transistor. The control signal determines which transistors are turned on and off, enabling the desired current direction and magnitude. Implement current sensing option. If precise current sensing is required, you can incorporate current sensing resistors or current sensors in the HV circuit. These components enable monitoring and feedback control of the current flowing through the load. Test and debug. Before connecting the load test and debug the HV, verify the correct operation of the control signals, ensure proper switching on the transistor, and measure the voltage and current at different points to validate. Basically, you can test from the software like Proteus or where you can choose better. you use another option from this verification. You must know the using of the breadboard. Connect load and finalize circuit. Connect the load such as a motor or actuator to the each bridge circuit. Ensure that the load is within the rate specification of the transistor and power supply. Double check connection, secure the circuit components properly, and finalize the HB assembly. You must implement the safety measures like fuses, our current protection, thermal protection to prevent damage to the circuit and ensure safe operation. It's important to note that the specific design and methodology can vary depending on the application requirements, transistors, drives, and other factors. Always refer to transistor data sheets, application notes, and evident later for detailed guidelines and best practice with constructing the HB with VGTs. Product specification. Basically, the voltage rating bridge should be able to handle the voltage levels, and important to choose transistor driver ICs other components. Current handling capability. Consider the maximum current then that the HB needs to handle to drive the load effectively. Select transistor power devices and associate components such as resistors and capacitors with appropriate current ratings to avoid overheating and device failure. Power dissipation. Power dissipation refers to the amount of power that is converted into heat during operation. Efficient HPB design minimize power losses and dissipate heat effectively. It maintains the sustainability. Pay attention to the power dissipation calculation and choose up components with the low on state and resistance ready or on and efficient the thermal characteristic. So this is our protest stimulation. I explain the basic purpose, how it's work. Let me explain. So this is the button on of like is when moving current is flowing through this and enter into the this circuit, and the resistor R and give it enter into the autocoupler, and is lights emit from this transistor is on and is the wave path from moving to the voltage divider from this to enter into the this transistor and going to the motor. So it connects in this way. The next path is to be, so this same procedure is also in this direction. The next the thing is to be open, and this path flow through this, and the path flow through from this side to the enter into this, and in this way in this way the old current is given to this side from. So this is our product desired stimulation. The next thing is PCB layout. The there is the 3D viewer. So basically this is our automated test bench. In this way you basically all about all know the functionalities, and so we must check and test the desired product for your information and for your circuit. And the next thing is the this our desired components we use in the 127 transistors and 122 transistor, two push buttons, 1K resistor, and 4007 diodes, and the one thing is the optocoupler 817. So all these functionalities written in there you must watch and read from this. And the next thing is the push button. When you pressure is applied to the push button actuator of a push, the button switch the internal spring and contacts and depressed, causing stable contacts on bottom of the switch type. The next component is the resistor. You must all know the functionality of the resistor, what we use. Resistors are one of the most common and impact components in electronic circuit. The next is optocoupler at once, and you must all about this. I explained you the before. So this is our applications. The next is mathematical modeling. To analyze the behavior of HPH circuit with BJTs, mathematically we can consider the simplified model. Firstly, identify the BJT transistor characteristics. Beginning that determine the electrical characteristics of the specific BJT used in the H-bridge circuit. These include parameters such as base emitter, voltage drop, conductor emitter, saturation voltage, current gain, and switching times. The next, analyze individual transistor operations. Study the behavior of each transistor in the H-bridge circuit separately. For example, consider the NPN transistor in the upper left position and PNP transistor in the lower left position. analyze their voltage current relationship, switch on and switch off characteristics, voltage drop and access the collector emitter junction. So all these instructions given to this you must know and read. So this is a data sheet of the our desired circuit, and then this is a PC advanced data sheet. So all over these components is of breadboard. You must know the use of breadboard. You can test and all the functionalities you verify that from the circuit. So I also check from this circuit. I hope you those this is our application at bridge you must read. So I hope you understand all our concept. So if any queries about regarding the circuit, you can must know and comment from my YouTube channel. Oh, Lafis.